This is Survey of Economics, PowerPoint Lecture 1.2 that goes over the basics of demand behavior. And so here are our objectives for this PowerPoint: to learn the law of demand, to learn the construction of and interpretation of demand schedules and curves, to learn the determinants of demand, to learn the shifts in the demand curves and how they differ from movement along the demand curve, to learn the concept of utility, which I've already mentioned, and to introduce the idea of marginal analysis, which will become much more important to us when we deal with supply behavior, and then finally to deal with the idea of the price elasticity of demand, which actually is a way of addressing something within the law of demand, which we'll get to. Okay. Law of demand, very simple. Negative correlation between price and quantity. Okay, as price goes up, quantity demanded goes down. As price goes down, quantity demanded goes up. Another way of phrasing it is the more you ask for something, the less of it I'm willing to buy. The less you ask for it, the more I'm willing to buy. From that law, we have the following schedule. Okay, and you see it models the law of demand. And one thing to mention, when it comes to a law is an axiomatic statement, meaning that it's universally true. There are very few laws in economics. Okay, people always talk about the law of supply and demand. There really isn't a law of supply and demand. There is a law of supply and a law of demand. All right, but at any rate, this is the schedule that comes out of that, and you can see it models it. For a lower price, the price of $2, they'll demand 300 fish sandwiches in a week. For the price of $10, they'll demand 60. Okay, so as price goes up, quantity demanded goes down. As price goes down, quantity demanded goes up. From that schedule, we can draw the following demand curve. Now, you'll note that what we do is we have the price on the vertical axis and the quantity demanded on the horizontal axis. That's a fairly standard way of doing it. You'll also notice, and this comes out of the demand schedule from the previous slide, that what we're positing here, what we're proposing, is a linear demand curve. Typically speaking, demand curves are not linear, they're curvilinear, but for simplicity's sake, we deal with just a straight line, okay, so that it's a linear model, so that you have uniform changes, okay. For every $2 drop in price, okay, which is the rise, you have a run of 60 units. For every $2, 60 units. Okay, and what we do in micro, I don't do it in Survey of Economics, but in microeconomics, we then go through, just for some kind of fun, and go through kind of linear algebraic manipulations to determine different prices, different demands, and then ultimately to get with equilibrium when we enter supply into this. But for now, it's just, think about that. All you're doing there is you're drawing the schedule, okay? Now we deal with the determinants of demand, okay, and what determines the demand for a good. Okay, and so the first of them you see here, now you might want to sit down for this because this is like groundbreaking. This is like Nobel Prize type stuff, okay? Consumer tastes. What that means is if consumers like the product, they'll buy it. If they don't like the product, they won't buy it. I know, that's a toughie. Let's sit down and rest on that for a minute, shall we? Now, the second one, also relatively intuitive. It has to do with income levels. If income goes up, if I make more money, if I have more money, okay, I'll demand more, I'll spend more. This is what I refer to as the drunken sailor on leave phenomenon. If I've got cash in my pocket, there's a very high likelihood that I'm going to spend more of it. The more cash I have, the more I'm willing to spend. The less cash I have, the less I'm willing to spend. Now that holds true, and this is generally true for the law, for normal goods. Most goods that you think about are normal goods. But the opposite is true for inferior goods, so that as my income drops, my demand for an inferior good will go up. Take, for example, new cars versus used cars. New car, that's a normal good. As my income level goes up, I'm likely to demand more new cars. But as my income level drops, I'm likely to settle for a used car. Okay? The same thing is true, for example, one of the things is if you've ever been to the grocery store, you see the distinction between butter and something like shed spread. Okay? Butter is a dairy product. Butter is more expensive. Butter is a normal good. It's superior. Okay, so as my income goes up, my demand for it will go up. I'll shift from buying the shed spread nastiness to actual butter. Shed spread has absolutely no relationship to a dairy product whatsoever. Okay, it's like when you go to the movie theater and have buttered popcorn. What you're putting on that popcorn has no relationship to butter whatsoever. One of the interesting things, just kind of as an aside, in Canada, the dairy producers lobby has been so successful in the Canadian legislature that they've passed a law that non-dairy products that are substitutes for dairy products, like shed spread, are not allowed to be the color yellow. They're not allowed to be the same color as dairy products, so that you can tell in an instant that they're not a dairy product. Okay, so with normal goods, as income goes up, my demand for the goods is going to go up. But as my income goes down, I'll settle for cheaper stuff, inferior goods. Another of the determinants of demand is consumer expectations. Now, what this means is this is a self-fulfilling prophecy, and we'll deal with it at greater length when we deal with shifts in the demand curve. But this is a self-fulfilling prophecy. And the reason I say it's a self-fulfilling prophecy, give you a classic example. Let us suppose that I'm in the market to buy a swimsuit. Now, I know that during the summer, demand for swimsuits is much higher. So I suspect that after summer is over, this is my expectation, that after summer is over, to clear everything out, all the retailers that are selling swimsuits, okay, are going to drop the price of them. So what I'll do is I'll hold off. I won't rush to the store and buy that swimsuit. I'll wait till October when they're on sale. All right? Well, because I hold off buying it, because I hold off going to the store, demand is going to drop for the thing, and that's going to lower the price. So it becomes a self-fulfilling prophecy. My expectation that the price is going to go down compels me not to buy it. Because I don't buy it, the price goes down. So it's a self-fulfilling prophecy. Where you see this the most is, for example, in equity markets. If you look at the Dow Jones or the S&P 500 or the NASDAQ, this is what we watch. This is a self-fulfilling prophecy. People believe that the price of a stock is going to go down, so they sell it off now. Well, because they sell it off now, the supply of it goes through the roof and the price drops. Okay? Now, the other one is the relative price of other goods. This is not exclusively, with what we're going to get into in a minute here, substitute and complementary products. But what it deals with is the idea that all goods in a market are related to one another. Okay? This flows ultimately from the assumption that we have on limited resources, on scarce resources. I have so much money to spend. Okay? If they jack up gas prices to $3, $3.25, $3.50, that leaves me with less money to spend on other things. So even though they're not really, you can't see the connection between the goods, if they raise the price of one good, that leaves me with less money to buy any other goods. Okay? And we'll deal with that more when we deal with substitute and complementary products, because there the relationship is a little bit easier to see. And then finally, the final of the determinants is the number of consumers in the market. The more people there are in the market, that'll drive demand up. That'll drive the price up. The fewer consumers there are in a market, price will go down, demand will go down. We see this best, the clearest example of this is something like an auction, okay? If you're auctioning off something, whatever that something may be, and you have 100 people that come in to bid on it, that's going to have a pressure to increase the final price of the product. But if you go to an auction and you're the only person there, you can pretty much dictate what price you're going to pay for it. All right. So the number of consumers in the market matters considerably when it comes to shifting demand. The more consumers there are going to be that want a good, the more the price is going to go up. This brings us into what I just hinted at, the idea of substitute products, and we'll deal with complementary products too. Substitute product is very simple to understand. Substitute products are two finished products. They can be intermediate goods as well, I suppose. They're two products that serve the same function, that do the same thing, okay? They are competitors with one another. Classic examples, Coke and Pepsi. Restaurants of the same type. Restaurants in general are not necessarily in competition with one another. Restaurants of the same type are in competition with one another. So if you have two seafood restaurants or two Italian restaurants, they're in competition with each other. But an Italian restaurant is not necessarily a substitute product for a seafood restaurant. It depends on what people want to eat. Okay, like for example, if you can go out for Italian food or you can go out for Indian food. They're not really in competition with one another. To some degree they are, because to some degree everything is in competition with everything else. You only have so much money to spend. Are you going to spend it on Italian food? Are you going to spend it on Indian food? But that really has a lot more to do with consumer tastes. When we're dealing with substitute products, these are two products that serve the same function. Coke and Pepsi, Ford and Chevrolet, Apple and Microsoft, iPhones and Samsungs and Motorola's and LG's, okay? These are all substitute products. And it's fairly intuitive to understand what the relationship's going to be. Look at this. If the price of one product, okay, goes up, that means the demand for that product will go down. And if the demand for that product goes down, that means the demand for its substitute will go up. In other words, if Apple jacks up the price of their iPhone, fewer people will demand it. Because fewer people are buying the iPhone, more people will be buying Samsungs and Motorola's and LG's and things like that. Now, that's not universally true. We'll get into this when we get in much later in the micro panel on the idea of the different types of markets and imperfect markets. As it works out, for example, in this market, cell phones, that's a monopolistically competitive market. People have a lot of brand loyalty is what that means. We'll deal with that later when we get there. But I'll give you an example of Coke Pepsi. My family was Coke drinkers in the early 70s. Okay, and well, the Coke drivers went on strike. And so the price of Coke went through the roof because there simply wasn't enough supply of it at the grocery stores because the Coke drivers had gone on strike. We switched over to its substitute product, Pepsi. Okay, that had a lot to do with it. The drivers really hurt Coke with that strike. That strike was in like 73 or something like that, and it really made a jump off point for Pepsi. Okay, so that's substitute products. Now, the other thing that's a little bit harder to understand, no, it's not harder to understand, is complementary products. Complementary products are two products that go together, okay? And typically in economics, they lump complementary products together. I don't. There's a difference. There are two different types of complementary products. There are integral complements and there are enhancing complements. And I'll give you an example, okay? The integral complements are products that cannot function without one another, okay? So for example, a computer and microchips. A computer cannot function without microchips. Okay? A cell phone and microchips cannot function without the other. Now, this is usually, okay, a one-way relationship. Because, for example, in our example here, microchips can function without a computer. Cell phones have microchips, okay? So even though you're not buying a computer, you're still going to have a microchip. You got to take a time one time and figure out how many microchips you currently are using. You've got one in your cell phone, you've got them in your iPad, you've got them in your iPod, you've got them in your computer, you've got them in your laptop, you've got them in your desktop. Microchips are everywhere, okay? And they are very dependent on the technology market. Okay, now, the second thing is really what we're dealing with when we deal with, well, one of them can work without the other, is a quasi-integral component. Okay, this is a condition in which one of the products cannot function in its intended use without the other product. Digital cameras, batteries, flash drives, and computers. Okay. And the final category is enhancers. Okay. With an enhancing complement, both of the products can provide utility. They have some use value. They provide a benefit when used on their own. But somehow they increase the enjoyment of one another. So what you have is, and we haven't really dealt with utility, we're going to deal with that in just a minute here, but what you have here is you have two products that can be enjoyed on their own, but when used in combination, they increase the enjoyment of both. A typical example of this is something like movies and popcorn. I'm like a Pavlovian dog. Okay, I can't go out to the theater and sit through a movie without having popcorn. I just can't. Since I was a kid. All right. Now, technically speaking, you can watch a movie perfectly reasonably. When I'm at home watching a movie, I don't always have myself a big bowl of popcorn. Okay, I can sit and enjoy the movie perfectly well. You can sit down and eat a bowl of popcorn without a movie on. They are both, you can use either of them independently, but somehow when you add them together, they improve the enjoyment of both. And you have lots of different examples of this. Okay, pie and ice cream. This is why when you go out to the restaurant and order apple pie, they ask, would you like ice cream with that? It's going to improve both. You can enjoy pie on its own. You can enjoy ice cream on its own. But when you put them together, it increases it. All right? And so what we deal with, we're now in the exact opposite relationship of substitute products. What we dealt with substitute products was if the price of one of them goes up and therefore the demand for it will drop, the demand for its substitute goes up. Well, now you're in the opposite position. If the two products are complementary and the price of one goes up, hence the demand for it will drop, the demand for its complement will drop as well. Okay, and this is specifically true of the integral complements. Okay, so if the price of computers goes up and therefore the demand for it goes down, well, then the demand for microchips is going to go down. This is something we deal with in technology markets. Okay, like a few months back in September, when the second quarter returns for Apple finally came all the way in, and their introduction, and this happened actually in February as well, when they introduced the iPhone 10, and the demand for it was actually much lower than they expected. Okay, it was a fairly lackluster introduction. That meant demand for the iPhone 10 went down. And because the demand for the iPhone 10 went down, the demand for microchips went down because they're complements. In fact, just a few days ago, Apple announced that they had, because of the iPhone 10 and then the XS and XS Max, which have just recently in September been introduced, because demand for them is not what they expected it to be, they made the announcement 2 days ago that they have a stockpile and they won't be buying microchips for a while. And the microchip market tanked on that day. I sat there and watched it on Bloomberg. The microchip market just tanked on that day. That's integral complements. Now, with enhancing complements, it's not quite so strong a relationship. If the price of movies goes up, the demand for popcorn will be affected, but it won't be affected as much as if they were integral components. Now we deal with a concept that often escapes students. There is a difference between movement along a demand curve and a shift in the curve itself. All those things we were talking about with determinants of demand, that's going to create a shift in the demand curve. And we'll look at that, what that looks like in just a minute. But a price change, okay, is going to create movement along the demand curve, all right, that already exists. And we'll take a look at that. So what I'm saying is, if here's our original demand curve, okay, that's what our original demand curve looks like, not dissimilar to the one we introduced earlier. If there's a price change, that's going to cause movement along this curve, okay? Drop the price, demand goes up. Increase the price, demand goes down. And you see here the quantity demanded and the price. Okay, so we put that together just as we did with our original schedule. That's not a shift in the demand curve. Price won't cause a shift. What's going to cause a shift is any of those determining factors. Okay, so if we look, for example, and this is why income, for example, okay, if incomes increase, if this is a normal good and incomes increase, the demand curve will shift this way, okay? And what you see that means is that for any given price, the demand will go up, all right, at any given price level. This will be true if incomes go up. This will be true if more demanders enter the marketplace. This will be true if, for example, if one product increases its price, which will be movement along this demand curve, its substitute product will shift outwards, okay? And so the determinants of demand that we went over, they're going to cause a shift in the demand curve. They're going to cause it either to increase demand, which is an outward shift, or decrease demand, which is an inward shift. When we go to changing the price, we're just moving along the line. We now deal with the concept of utility, which I've introduced before. Okay, this is basically the use value of a thing. Okay, it's the benefit gained from the consumption of a commodity. And right here we run into trouble because, and this is one of the differences between the analysis of demand and the analysis of supply. In supply, you have certain very objective concepts, such as revenue, price, profit. These are all mathematical relationships. They're all fairly. When it comes to demand, much of demand is going to be based on utility. Utility itself is a very murky concept. Not because it's hard to understand. It's not hard to understand. If you gain benefit from the thing, it has utility for you. The problem is that utility is very subjective. It varies from person to person. Okay? Some folks gain benefit from the consumption of peanut butter. Myself, I can't stand peanut butter, so I gain no utility whatsoever. In fact, if I even smell peanut butter, I experience negative utility. Okay, so there really is no objective way of looking at this. It becomes very subjective. With that in mind, and as we move forward with that in mind, we do have, and this is a more objective idea, the distinction between total and marginal. And we're going to deal with this quite a bit, okay, particularly when we get to supply, so we may as well tackle it right now. Marginal is the change in the total. Total is just the summation of all things. Okay, whatever it may be. In the terms of utility, we simply total our utility from the consumption of products. Marginal utility is the change in total utility from the consumption of one additional unit. Okay, If we typical easy example of this using numbers that I can work out in my head, take an example from, like, say, football. Okay, where you have a running back, and if the running back runs the ball 20 times, and the average is 5 yards a carry, that's 100 yards. Well, if they carry it a 21st time, and that increases their total to 103 yards, with a 3-yard carry, that 3-yard carry is marginal. That's a marginal increase in the total. Every time they carry the ball, it's a marginal change in the total, either positive or negative. Same thing is going to happen with utility. We'll deal with that when we deal with marginal costs, when we deal with marginal returns, etc. Now, this is often referred to as a law, but it's not entirely law-like. Remember, we introduced earlier in this PowerPoint that, well, really, for something to be a law, it is axiomatic, meaning that it's universally true. Diminishing marginal utility is generally true, but we can come up with things that maybe it's not true. Okay, so for example, if you have diminishing marginal utility, each successive unit consumed yields less utility than the preceding unit. This is the example I always use with this is McDonald's French fries. I don't eat at McDonald's. I think McDonald's is crap, but every once in a while I get this bizarre craving for McDonald's French fries. So I go there and I buy myself 2 giant orders of McDonald's French fries. And when I first enjoy those French fries, when I first grab the first handful and put it in my mouth, I experience my maximum utility. I'm craving it. I'm starving for it. But as I eat more and more of them, each successive fry I eat, my marginal utility, okay, my increase in my total utility, my marginal utility, each one gives me less and less and less enjoyment until I'm to the midway through the second order and they taste like cardboard and I can't stand them, and that's the end of that craving for the next 6 months, and I end up throwing them away. Okay, you reach the point where you have, based on diminishing marginal utility, you reach the point where you're going to end up with negative utility. Okay, but now let's try to think of things that may not be true of, that each successive unit gains less than the preceding unit. Back in my drinking days, and I haven't had a drink in 16 years, but back in my drinking days, okay, alcohol. This was not true of alcohol, okay, particularly for some bizarre reason, tequila. But when I would have the first drink, it was good. It yielded me a utility. But the second drink gained me even more utility. Then the third gained me even more utility. Then it started to taper off, 4th, 5th, 6th, 7th, 8th, okay? Till by the time I've had my 13th or 14th drink, I'm now experiencing negative utility, as reflected in the fact that I end up throwing the whole thing up, all right? So diminishing marginal utility doesn't, we can think of examples where it doesn't actually hold true. It's generally true, okay? It's going to be modeled in supply by diminishing marginal returns, but diminishing marginal returns is much more law-like, and we'll deal with that when we get there. Now we look at the utility curves, and notice what we've said here. Here's marginal utility. It models that idea of diminishing marginal utility. Each successive unit, first unit yields us 10, second unit yields us 9, third unit yields us 7, fourth unit yields us 5. So with each successive unit, we get less marginal utility, less utility from each unit. And you see that it's not entirely unified. It looks as though with the fourth unit, I'm experiencing 5, but with the fifth unit, I'm only experiencing 2. Then with the sixth unit, that drops to 0. With the seventh unit, I'm now at -2. And with the eighth unit, I'm at -5. Okay. Now, what the example here shows is that here's marginal utility. Marginal utility is the change in the total utility from the consumption of one additional unit. And you can look at this. This is a model of that. This models this. Okay, so our diminishing marginal utility is reflected here with the straight downward movement. Okay, but what happens with total utility is our total utility increases till we reach some point. And you'll notice it's at the 6th unit. Then it evens out, and then in units 7 and 8, the total utility actually goes down. That's because over here in the marginal utility, they're negative numbers. Okay, the consumption of that 8th unit is a negative number. That's why the total utility will drop. But until then, okay, so if we just do the math real quickly in our heads, the first utility yields me 10 units, okay? The second unit yields an additional 9. That brings me to 19 total. The next unit yields an additional 7. That brings me to 26 total. The next unit yields an additional 5. That brings me to 31 total, etc., until we start to experiencing negative utility, in which case the curve starts to turn downwards. All right?